Okay, today we will start normal distribution, one of the part of probability distribution. In previous lecture we have studied about Poisson distribution, and then before binomial distribution. And we have successfully finished binomial distribution and Poisson distribution. So from today we are uh, starting with normal distribution, one of the part of probability distribution. Actually, this is the normal distribution, and it is continuous distribution. Remember it. In our previous lecture, Poisson distribution was for discrete. So this is the continuous distribution. Continuous means there is a limit between range. So far we have dealt with the discrete distribution, where the variates take only the integral values, but the variate like temperature, height, weight can take all values in a given interval. Such variables are called continuous variable. Actually, temperature, height, weight, etc., etc., measurement will take the continuous variable. So continuous, let f of x be a continuous function, y equal to f of x. Then mean will be minus infinity to plus infinity x into f of x dx. This is the actually mean from the random variables, the probability density function. We already known about mean is this x into f of x dx, and variance will be minus infinity to plus infinity x minus x bar whole square. This is the just for notation. X bar means mean, x bar means mean, and f of x dx. This will give the variance of continuous function. Now, where f of x is called the probability density function in random variables. So, probability density functions, of course, must be greater than or equal to 0, because probability can never be negative. Probability can never be negative. This is why always remember this. This will be non-negative for any values of x. Second condition will be total probability. That means minus infinity to plus infinity f of x dx. That means total probability will be must be 1. This is the continuous function actually, minus infinity to plus infinity 1. And if we take integration a to b f of x dx, then must be we get a probability p. This will be the probability p. Let us consider an example for this. The probability density function f of x of a continuous random variable is defined by this. That means f of x is the continuous random variable function, and this is the probability density function also. This equals to a divided by x cube if x lies between 5 and 10. Okay, 5 less equal to x less equal to 10. F of x will be 0 otherwise means other value for other values of x. Find the value of a. That means we have to find out the constant a. Here we are given f of x equals to a divided by x cube. Okay, f of x equals to a divided by x cube, where x lies between 5 and 10. Since f of x probability density function, you must know f of x is the probability density function. So we have to integrate with what? A to b f of x dx equals to what was 1. This is the properties of probability density function. Total probability what will be 1. So we can write a to b in 5 to 10 f of x dx equals to what? 1. Now just taking integration x cube integration, what will be? This can be written as x to the power minus 3. Okay, x to the power minus 3 integration, what will be? X to the power minus 3 plus 1 divided by plus minus 3 plus 1. That means x to the power n formula, we get minus a divided by 2s x cube. Then we have to take this limit within third bracket, upper limit 10, lower limit 5, definite integral. This equals to 1. And this is the value of x, remember it. This value because this integration with respect to x. This is why this is the value of x. Now putting the value of x equal to 10. Okay, x equals to 10, we get this, and putting x equals to 5 minus uh, upper limit minus, then we have to put lower limit, then we get a equals to this. Understand everybody?
Yes, sir.
Yes,
Simple
sir.
integration. Simple integration. Just putting upper limit, we have to put minus, then putting lower limit, putting the values of x equals to 5 in replace of x. Remember it. Now another random variable given, f of x equals to 0 for x less than 2, f of x equals to this for x lies between 2 and 4, otherwise x. That means if x is greater than 4, then equal to 0. So that it is a probability density function. I have to prove that this is a probability density function. Now this is the given function, f of x equals to 0 for this condition, f of x equal with this for this condition, x lies between 2 and 4, and f of x equals to 0 if x greater than 4. If f of x is probability density function, then we must satisfy this. Okay, minus infinity to plus infinity f of x dx equals to 1 must be. That means there are actually limit, lower limit 2 and upper limit what, 4. 2 because this function lies between 2 and 4. Okay, so 2 limit 2 to 4 f of x dx. Okay, f of x means what, 1 by 18 twice x plus 3, 1 by 18 twice x plus 3. Now taking integration, x integration what will be, x square by 2. Okay, x to the 1 plus 1 divided by 1 plus 1, x to the n formula. This why x square 2x square by 2, that means 2 to cancel, only x square. So this will be only 3x. Okay, integration of 1 will be only x, remember it. Integration of 1 what, x. This is why 3 into x. Now putting the limit within third bracket, so lower limit is 2 and upper limit is 4. Now putting x equals to 4 using upper limit, x equals to 4, we get this. Then minus putting x equals to lower limit, okay, 2, then we get this equals to whole 1. So this is proof that total entire probability density function, entire probability what, 1. That means this properties has been proved. So we can say that this is a probability density function. Another one, question number 2, f of x greater than 0, f of x greater than 0 for x lies between 2 and 4. That means f of x is the positive function, positive density function. Hence the given function is probability density function, we have proved. Understand everybody?
Yes, sir.
Very easy. Just if you practice one time, of course you can do. Now another example, the diameter of an electric cable is assumed to be continuous random variable with the probability density function f of x will be this, and x lies between 0 and 1. Number one, verify the above is a probability density function. That means we have to prove this is a probability density function like before example. Now we must know minus infinity to plus infinity f of x dx equals to 0 to 1. Limit will be what, 0 to 1, lower limit 0, upper limit 1. Then f of x equals to what, f of x into 6x into 1 minus x. Now just multiplying 6x between these two, then 6x minus 6x square, just taking integration, 6x square by 2, that means 3x square, then 6x cube by 3, that means twice x cube, just taking integration. Now putting third bracket within limits and putting the limits. Now if x equals to 1, then putting upper limit in replace of x, we get 3, then 3 minus 2, then minus putting lower limit x equals to 0, we get whole 0. This is why this is 1. That means entire limits, uh, total number of probability, total probability, the sum of total probability density function is what, 1. Secondly, f of x is greater than 1. This is why x lies between 0 and 1. This is the condition. Hence the given function is a probability density function. Number 2, find the mean and variance. We must know mean is the formula for continuous probability density function. For continuous probability density function, mean equals to what, minus infinity to plus infinity x into f of x. Just putting the values of f of x, we get this. This is the integration, definite integral. Now variance equals to, this is the variance formula for the variance of what, continuous probability density function. So minus infinity to plus infinity x minus x bar whole square f of x dx. X bar means what, mean equals to what, actually half. X bar equals to what, half. This is why x minus half whole square f of x dx. Okay, this is actually a minus b whole square formula, a square minus 2b plus b square formula. Then multiplying with these two, we get this 3 and 2 makes what, 5. This multiplication 4. So just taking integration for individual term, we get this, and putting the limit, upper limit 1, we get 1 by 20. Understand everybody?
Yes, sir.
Now another example for a continuous variable. Continuous random variable has probability density function. PDF is what, actually probability density function. F of x equals to k into e to the power minus x by 5 for x greater or equal to 0, and this f of x will be 0 otherwise. Otherwise means what? For negative values of x. Then the value of k is what? We have to find out the value of k. Very easy. You must know minus infinity plus infinity probability density function of f of x dx equals to what will be 1. Okay, so these can be taken as two parts. How? Minus infinity to 0 plus 0 to infinity. That means in any, this is the properties of definite integral. We can divide the whole integration into two parts. How? Dividing the limits. Minus infinity to 0, then 0 to infinity. Actually this can be written as minus infinity to plus infinity. This will be whole sum 1. Now minus infinity to 0, probability density function what? 0, right? Or otherwise, that means negative values f of x, all f of x values what? 0. This is why this is equal to 0. And this probability density function for x greater than 0, that means 0 to infinity, what? K into e to the power minus x by 5. Just taking integration of this, e to the k is the constant, e to the power x formula what? E to the power x, just dividing with the coefficient of x. Coefficient of x what? Minus 1 by 5. Minus 1 by 5 is the coefficient of x. Then putting the limit within third bracket. Now putting upper limit infinity for x. Then we get e to the power minus infinity. E to the power minus infinity what? 1 by infinity, 1 by e to the power infinity. But e to the power infinity what? Infinity. So 1 by infinity what will be? 0. This is why we get the values k equals to 1 by 5. Now if the probability density function of a random variable x is this, that means very heavyweight function. Okay, seems to be complex. F of x equals to this, that means k into x to the power alpha minus 1 into 1 minus x to the power beta minus 1 for x lies between 0 and 1, alpha of course positive and beta also positive. Otherwise for other limits will be 0. Find the value of k and mean of x. Now if f of x is a probability density function, we must know sum of the density function, probability density function of this will be 1. Total probability will be 1. So here you must know the limit given 0 to 1. Okay, this is the f of x actually will be what? 1. So this can be written as k into x to the power alpha minus 1, 1 minus x to the power beta minus 1. This is the actually beta function. Okay, beta function, that means beta mn. This can be written as beta mn. So beta mn equals to what? Gamma alpha gamma n divided by gamma plus m plus n. This is the formula. That means this is the beta alpha beta function, and m for alpha and n for beta. Gamma alpha gamma beta divided by gamma alpha plus beta. This equals to k equals to this. Now mean equals to what will be? This is the formula, x into f of x dx. The x into f of x means what? This is the given function. This is the f of x. Okay, so k into 0 to 1, x will be what? Alpha plus 1 minus 1. That means alpha plus 1 here in replace of alpha plus 1. So putting the value of k in equation 1, value of k, we get this, k equals to this. Okay, then x to the power, this is also beta function. Beta function for what? Gamma alpha plus 1 into gamma beta, just alpha for alpha plus 1. This is the difference. Then this alpha plus 1 can be written as alpha into gamma alpha. alpha into gamma alpha. Okay, so gamma alpha will be cut, and this will be the result. Gamma alpha plus beta, gamma alpha plus beta also cancelled, and this gamma alpha plus beta plus 1 equals to, actually you can write alpha plus beta into gamma alpha plus beta, alpha plus beta into gamma alpha plus beta. This is the actually result. Okay, this is the actually definition of beta function. Beta function 0 to 1. This is the first Eulerian integral or beta function. Okay, 0 to 1 x to the power m minus 1 bracket 1 minus x to the power n minus 1 dx, denoted by what? Beta mn. This is actually beta mn. Beta mn means what? This function. Remember it. M x to the power m minus 1, 1 minus x to the power n minus 1. This whole integral can be written as beta mn. Okay, this is the beta function. Another function 0 to infinity e to the power minus x, x to the power n minus 1. This is actually what? Gamma n. This is the gamma function, and it is also called second Eulerian integral or gamma function, of course, for n greater than 0. That means e to the power minus x, x to the power n minus 1 dx can be written as gamma n. Okay, this is the actually. Also remember, beta mn can be written as beta nm also, and gamma 1 equals to what? 1. Gamma 1 equals to 1. And gamma n plus 1, this is the formula used in our previous example. Gamma n plus 1 equals to n into gamma n. Okay, gamma n plus 1 can be written as n into gamma n. That means gamma n plus 1 can be written as also n factorial. This is also formula for n is positive. So beta mn also can be written as gamma n divided by gamma m plus n. This formula used in our previous example. We have used this formula and this formula also. These two formula I have been used. Okay, beta mn equals to gamma n divided by gamma m plus n, and this is the gamma n plus 1 equals to n into gamma n. Remember it. So clear? This is the actually beta function. Okay, gamma alpha gamma beta divided by gamma alpha plus beta. This k equals to this. This is the value of k. Again mean equals to this. This is also beta function. Beta function for what? M equals to what here? Alpha plus 1. N equals to what? Beta. So formula will be what? Gamma alpha plus 1, gamma beta, gamma alpha plus 1 plus beta. That means this. And this can be written gamma alpha plus 1 can be written as alpha into gamma alpha. How? Actually, how? This. Gamma alpha plus 1 equals to what? Gamma alpha plus 1 equals to what? Alpha into gamma alpha. Okay, okay, and using this formula. Understand everybody?
Yes, sir.
Okay. Okay, now what is actually normal distribution? Now we will define the normal distribution. Normal distribution is a continuous distribution. It is derived as the limiting form of binomial distribution for large values of n. P and Q are not very small. P and Q are not very small. The normal distribution is given by the equation f of x equals to 1 divided by sigma sigma into twice root over twice pi. Okay, then e to the power minus x x minus mu whole square divided by 2 sigma square. This is the actually probability density function for normal distribution. Remember it. You have to remember this equation. F of x equals to what will be? F of x equals to 1 divided by sigma square root over twice pi e to the power minus x minus mu whole square divided by 2 sigma square. This whole represent normal distribution. Where mu equals to mean, sigma equals to standard deviation, and pi equals to what? 3.14159. And for any probability density function, if x lies between x1 and x2, this can be written as the integration of this. This is also probability density function for limit, if limits is given. And z equals to what? X minus mu by sigma, remember it. Then we can write f of z equals to this. Just putting z equals to x minus mu by sigma square, x minus mu by sigma square, we can write the probability density function for normal distribution. Okay, on substituting z on another form of z form. This is the standard normal distribution for the z form. Here mean equals to 0 and standard deviation will be 1. Another and number equation number 2, also known that standard form of normal distribution. This is the standard form of normal distribution, where z equals to what? X minus mu divided by sigma. Actually, this is the definition of our normal distribution. And actually there is a mu will be what? Mean, and sigma square will be variance for this normal distribution. Mu and sigma square are the two parameters of the distribution, and the normal variate is often expressed by and mu sigma square, mu comma sigma square. The assignment of the probability is permissible. Okay, so total probability will be sum of the total probability for the normal distribution will be 1. Now we'll prove this theorem. So total probability density function, sum of the total probability for the probability density function of normal distribution will be 1. Okay, we will prove this now. The minus infinity to plus infinity f of x dx equals to minus infinity to plus infinity f of x, what will be? Probability density function of what? Normal distribution. That means 1 divided by root over twice pi e to the power minus half x minus mu divided by sigma whole square. Okay, this is the probability density function for normal distribution. Now putting z equals to x minus mu divided by sigma. Okay, z form of the f of z equals to. Okay, then this can be written as 2 divided by root over twice pi e to the power minus half z square dz. Okay, here 2 from where? Actually these two, actually minus infinity to plus infinity. Okay, minus infinity to plus infinity can be written as 0 to infinity by 2 times, because this is the actually even function. Okay, for even function we can write this even function. Odd function, you must know about the definition from Fourier series also. Fourier series finished in your course? Hello?
No sir, start kora hoyni ekhono.
Okay, but you must know what is odd function and even function. Of course, no. So for this function, we can write minus infinity to plus infinity 2 times into 0 to infinity. Okay, 2 times into 0 to infinity e to the minus half z square, because this is the even function. And for the even function, we can use these properties of definite integral 0 to infinity e to the power minus half z square. Now, if we take z square by 2 equals to t, substitution process. Okay, substitution process, if t equals to z square by 2, then we can e to the power minus t, and taking differentiation on both sides, 2z dz equals to 2 dt. Okay, then e to the power minus t dt divided by root over twice t we get, just putting the value of dz after differentiation. Okay, now e to the power minus t dt divided by root over twice t. So this can be written as root over 2, what will be? Root over 2 whole square, that means 2. So 2 will be cancelled, so only 1 by root pi 0 to infinity. This can be written as e to the power minus t to the power half minus 1. Okay, but in denominator we are getting t to the power half. Okay, then if you take it in numerator, then t to the power minus half, this will be t to the power minus half. So t to the power minus half can be written as t to the power half minus 1. T to the power half minus 1. So this is the actually gamma function. What? Gamma half. This is the gamma function, and gamma function formula what? Gamma Gamma function formula. This is the e to the power minus x, x to the power n minus 1 dx denoted by gamma n. Okay. This is the gamma n formula, second Eulerian function. If n here n equals to half, okay, e to the power minus x, x to the power half minus 1, half minus 1, okay, and this is the e to the power t variable, no problem. You can replace x as a t, any variable, e to the power minus t to the power half minus 1. This is the formula of what? Gamma half. And gamma half equals to what? Remember it, root over pi. This is the formula for gamma function. Gamma half equals to what? Root over pi. Gamma half equals to always remember root over pi. This is the gamma half equals to root over pi. This formula used in our probability density function. So this is the gamma half, and gamma half equals to what? Root over pi. Root over pi will be cut. Thus this is the one. So total sum of probability density function for the normal distribution is 1. We have proved this result. This is the one of the properties of probability density function of normal distribution. Okay.
Yes, sir.
Minus infinity to plus infinity, f of x dx equals to 1. This is the proof. We have proved. There may be any question like this. Prove that this equals to 1 for normal distribution. Okay. We have proved here. Minus infinity to plus infinity, f of x dx equals to what? 1 by using gamma function formula.